Good morning, everyone. Thank you, Roy. I'm going to talk about SD-WAN. SD-WAN is hot. It's getting deployed, but it's also evolving very, very fast, hence the title. When we started and launched Nuage almost 5 years ago, we talked about how we're going to automate networking, and we're going to do software-defined data center as well as software-defined wide area network. We called it SD-VPN at the time because the industry had not quite coined the term yet of SD-WAN. 5 years later, we have a lot of learnings. 135 plus customers worldwide that have deployed the Nuage platform. And the reason I say platform is because that was the thesis that we had when we started Nuage, which is that we wanted to automate networking from business users, wherever they might be, to the applications that they're accessing wherever they are, in the private DC, in SaaS, in public cloud, or increasingly in the telco data centers, NFV clouds. And in order to do that, you had to, and we built a platform rather than a point solution. And boy, has that been validated. And it's great to see that because the use cases that we are uncovering as we are getting deployed is what I want to talk about today. Because the SD-WAN, as it exists, the pure play SD-WAN, started off as really an evolution of MPLS VPNs to make those very highly automated self-service, on-demand, et cetera. But the fact is, having talked to a lot of customers and being involved in those use cases that we are working with them on, it's clear that if you talk to a typical CIO, CTO, CISO, what they are worried about is not only connecting branches together securely and quickly, reducing operational costs, et cetera, but what they are also worrying about is multi-cloud strategy. What are they going to do as the workloads are moving to public cloud, as applications are being consumed from SaaS, as their own data centers are getting automated? The threat landscape, if you will, the surface area is increasing dramatically. As it increases, there are more points of vulnerabilities. And so how do I have a network governance? How do I have a single pane of glass and yet make sure that I have the agility and the efficiency that I'm driving? So that's what I want to talk about, that how SD-WAN is evolving. And I want to focus on some of those use cases that are top of mind for the enterprise customers. So here's how we started. MPLS IPVPNs have been there for ages. They're not going anywhere, by the way, as Roy pointed out in the morning. But they're limited. And most importantly, they're highly manual in terms of provisioning. It takes a long time. So industry put their head together. We came up with SD-WAN. SD-WAN was about making it highly independent in terms of any network, any underlay, or any transport, any location, and not a proprietary, but any device, any x86 platform that allowed that service to be consumed on demand. So that's great. It's still focused, although, on VPNs and branch connectivity. So the question really is that enough for the enterprises that are getting transformed and how they are looking at, as I pointed out earlier, what is their meta question that they're asking? They're asking, how do I connect my business users to their applications? Number one, top of mind, is multi-cloud. Multi-cloud strategy, how can I have this single pane of glass for my VNFs, my VPNs, for my SaaS, have that common network governance across the board, be able to look at compliance if I'm a financial, be able to quickly audit my network. How do I do that when it's spread so far? How can I easily move my workloads from AWS to GCE maybe? Because the fact is, once I have done the work, I'm locked in. So how do I do that? And how can I make the entire experience and my network, my service, fully redundant and resilient across the board? The next question they worry about is value-added services. So they want to avail the network applications from either the branch or the cloud. They want to get rid of that bespoke clutter in their branch of different appliances and highly manual orchestration of those appliances. So they want to take advantage of the virtualized appliances, have some sort of a streamlined approach for that, or for applications that make sense, they want to consume from the cloud. How do they do that? And finally, end-to-end security. This is absolutely top of mind for them. How can they make sure that that entire sort of enterprise, domain-wide, is secure from every branch to any application there might be that the branch users are accessing? How do they make sure that they have that? So how do they make sure that they are able to make security as agile? How can they prevent east-west traffic? It's a well-known fact, well-documented. Vijay talked about it. The fact is, you have to protect. There's so much traffic east-west, but you have to protect it. You can't trust it anymore. It's no more era of hard shell and soft core. You can't trust even inside communications because the malware can spread laterally very, very quickly. And how can I finally detect threats enterprise-wide and take action? So how do I get that actionable insight? Then use the power of SDN to actually take action very, very quickly. So let's dive into each of these. But first, a translation of what that means in terms of SD-WAN as a service. All these things mean that as the service has to be very, very sophisticated. It has to be comprehensive in the network capabilities that it has. Because the fact is, if you do a sort of a look at all these things, multi-cloud, it's about seamless connectivity to private cloud, NFV cloud, public cloud, and SaaS. Network applications, it's about consolidation of those network applications, but the important thing is a streamlined management of those. You don't want a big stack of VNFMs and VIMs and the entire stack of that along with the stack of orchestrating the actual connectivity. So how do you do that? And how do you do this end-to-end microsegmentation, actionable insight? And underpinning all that, it has to be extremely scalable network control plane. It has to be that when enterprises need a choice of using multiple underlays, that flexibility and choice comes with some complexity that needs to be part of that service. And the ability to stitch. So these are all heavy-duty networking concepts that we've all worked on, but the main point here is that this is becoming a rather comprehensive, deep networking expertise service that has to be delivered, but it has to be very simple to consume. That's the challenge that we have. It has to be highly automated. It's complex underneath, but it's simple to consume and operate. So let's look at each one of this. So first challenge is about need for flexibility and choice of underlays. So it's about not only connecting my branch to an MPLS underlay or simultaneously to an ISP, an internet provider, or maybe a couple, or using LTE as also an uplink. But then the fact is not all branches are going to be connected to dual homed. So what happens if my headquarter branch that's connected to MPLS and internet loses the internet connection while the far end branch, one of the remote sites, is only connected to the internet? Now how does that site talk to the site, the headquarters? Because now you have an orphaned branch. So those are all the considerations that has to be taken into account. So let's look at that, because one is the fact that you need those multiple underlays. That's the fact. Everybody wants to break out in the underlay and use the internet. But then how do you stitch that SD-WAN overlay that's covering those branch sites and then seamlessly connect it to the overlay in the data center? Because NFV clouds, whether as they are being built, you'll have a mix of, as Roy pointed out earlier, you'll have a mix of virtual machines, containers, bare metal servers in different hypervisor technology. So how do you make a single API and connect these together? What do you need? So let's look at it. You need a single policy engine and orchestrator with the SDN controller that has network, that control plane that scales. But additionally, you need the capability, and these boxes that you saw here below pop up, they're software modules. The capability has to be built in the service in order to stitch those multiple underlays together. So in that case, you are not orphaning a branch if you have a branch that's only connected to the internet, but others connected to internet, but they lose that connection and they're connected only to MPLS. That capability has to exist. And then, how do you seamlessly go all the way to the actual hypervisor so that you're not breaking this automated service overlay chain? And for that, you again need that capability that I'm calling is a BR here. But that capability is about seamlessly getting IPsec and stitching it to a VXLAN perhaps all the way to that hypervisor, but all completely orchestrated with a single API and a controller. But then there is public cloud connectivity. So let's look at what it takes for AWS connectivity, because the fact is almost every enterprise that we talk to, they have some workloads that are going into a public cloud. In this case, I'm taking an example of AWS. Every enterprise has, multiple VPCs, a virtual private cloud that they're availing, and multiple departments have VPCs. So there's a ton of VPCs that are in AWS. Some of them are shadow IT. But the fact is, first and foremost, the enterprise has to deal with, and this is directly from the AWS website, you have to have heavy-duty work done and understand the options that are available in AWS to create those VPNs, first and foremost. And then you've got to orchestrate that connectivity within the VPC, between the VPCs, and back to the enterprise. And there's a lot of documentation available on AWS to do that. So here's the thing. To refactor a workload that's sitting in the data center and move it to the public cloud, there's already a ton of work that needs to be done. But then, if you have all this done and you take the trouble to do this, you're locked in forever. So how do you, at least from the networking perspective, make the governance consistent and seamless across the board, even when you are availing public cloud? So let's look at that. So this is the problem statement. We have public cloud that we need to get to. We need to connect each of the VPCs in the public cloud, a common, consistent overlay across the board, connected to all the branches that are dual home, using multiple underlays, and then availing some of the network applications that are in the NFV cloud. So I've talked about already the connectivity of the software capability and the modules that need to be part of the SD-WAN service in order to make it seamless from the branch over to the NFV cloud. What you need as well is the capability to convert those VPCs with software capability that's part of the SD-WAN in order to have those VPCs look like any other branch. So if a VPC looks like any other branch, all that work that you need to connect and back-end connectivity between the VPCs is all gone. And then what you do is you leverage the power of BGP, MP-BGP, because now that VPC is looking like just another branch. And you use dual homing techniques, whatever you have redundancy, resiliency, all built in the scalable control plane, but then you're orchestrating it on demand through the policy layer that's abstracting and providing the intent to connect these things together seamlessly. What that does, by the way, in the previous thing, is then it becomes very easy, or much easier, to move that workload from AWS to GCE tomorrow. Because you're taking that approach. You're not dealing with all those heavy-duty orchestration and API work that's required on the networking side in AWS. So that's very, very powerful. OK, let's talk about network applications. So this is absolutely, I'm sure everybody, this will resonate with everyone. There's tons of appliances in a typical branch. There's firewall, there's not as much WAN optimization because there's brute force approaches, but still, there's all these different appliances, very bespoke, orchestrated manually, et cetera, et cetera. And what enterprises are saying is, we want to avail this as part of the new SD-WAN service. Give that to us. The challenge is quite a bit, actually, because you need a consolidated platform, but you need a centralized cloud policy, and it has to seamlessly and tie in with the entire policy orchestration. So how do you do that? But first, a couple more things on the challenges. Imagine this. If the VNF is hosted in the telco cloud, it's in a controlled environment. The telco has complete control, management control. It's secure management-wise. And so to orchestrate the connectivity of a VNF in a data center that's controlled by a service provider is different than when you're looking at orchestrating a VNF now being deployed at a branch site. And it could be multiple branches of a customer, but it could be multiple branches of many customers. So how do you actually emulate that entire secure management that is existing in your telco NFV environment, but now make it as if these are micro data centers that are completely in your control? And how do you do that seamlessly and with orchestration that's very streamlined? So that's where, one of the approaches is it's the OS, which is, could be a KVM hypervisor, but the capability of SD-WAN, the routing and switching capability, all the networking that SD-WAN provides is built in inherently. And when that happens, you avoid the tromboning because it's not a VNF. SD-WAN is not a VNF now. It's part of the Linux. And as a result, when you want to service chain and appliances or virtual appliances within that branch, you're not tromboning back and forth to the SD-WAN VNF. So in other words, you're not creating the same spaghetti of physical wires into virtual wires, but it's a very streamlined and clean architecture. That's first. Next, what you're doing is you can take on a lightweight VNF and VNF-FM, Vim function, all part of the policy orchestration. So what that does is it allows you to use that same management and secure control channel that you have when you bootstrap that particular CP for the first time. When you're now deploying the other VNFs, you already have the secure channel. You don't need to bootstrap, authenticate, authorize every new VNF. So you have done that already. So it becomes very, very streamlined. And finally, you expose a single RESTful API up from the policy. So the top-level orchestrator is not really talking and making API calls to the CPE. It's just making API calls to the SDN controller or the policy. Of course, as I said earlier, there has to be flexible models of customers being able to avail these network applications. It can be something that's inherently built in. There are some examples I'm giving here in terms of what could be built in the CPE, but it could be the branch in box, which we just covered. But it could also be service chaining, which is a very nice streamlined service chaining when it makes sense of VNFs that might be hosted in the NFV cloud. And so the instantiation will look something like this, where you have complete flexibility of orchestrating right from the branch any VNFs at the branch device in the CO location for any VNFs that makes sense to be localized, and as well as much central telco cloud. So finally, security. So security is about prevention, detection, and response. And the current security model is very, very slow in all those three things. And yet, security is paramount. And so when we're making everything else agile, we can't leave security behind, clearly. And so what is the model? and what model should apply to this new world. And it's from first, the one in the middle, software-defined end-to-end segmentation. Microsegmentation is another term that's being used in the industry, but it's segmentation end-to-end to make sure that you're securing and limiting the threat surface, if you will. That's one. But it has to be across the board. It can't be just, security can't just be in the appliance and say, we've done it, we call it victory, we provide security in the appliance. That's not enough. The security has to be domain-wide, and it has to go all the way to that hypervisor in that data center, whichever data center it might be. And then it's about providing the detection capabilities with visibility and security analytics. And finally, it's about using that capability and insight to make it actionable and use the centralized and domain-wide knowledge that the SDN controller has to quickly implement policies anywhere in the network or the domain. So a little more details on that. Comprehensive and dynamic end-to-end security is about providing that visibility. You are in the data plane. If you are doing end-to-end, you are in the data plane in both this branch as well as in the data center. There's a lot of analytics that can be leveraged to provide insights into a flow. What are the flows? Who's talking to who? Are these allowed? Can be used for compliance, et cetera. But then you have the ability to automate that inside, because if there is any alarms that you get, then that alarm can be used to provide an automated response to quarantine a workload, to quarantine a branch, to service chain a appliance, or service chain it to a honeypot, see what more is going on. All those things are possible. And this is typically the issue here. So most VPNs that are implemented in most enterprises, this is the issue here. The problem is everything else, as I said, east-west, is soft. So if there's a partner that has access, given to an access to a certain application only, the problem is if that partner is compromised, which is the target store's breach, that's exactly this. If the partner is compromised, they get in the data center, and because it's a flat network and it's not protected, that can spread east-west, and everything else can be compromised. So that's a real issue. And hence, the microsegmentation can't be just in the data center, can't just be security in the branch. It has to be where that segmentation goes all the way so that partner can only talk to that particular application in the data center and nothing else, first and foremost. So you reduce the threat surface. Finance can talk to only finance applications. Sales can talk to only sales applications and nothing else. Once you've done that, even after this, if there is someone trying to get in, now what happens is it reaches a certain threshold crossing alarm, and using the SDN analytics, the policy controller immediately finds out about it. And what you can do then is, as I said earlier, you can start to service chain that traffic to a honeypot or a heavy-duty firewall. So that's how you can actually take more action on and understand what's going on. So finally, summarizing all that, SD-WAN, the way we see that evolving, is that it covers these top-of-mind use cases of the enterprises that are looking at multi-cloud strategy in addition to automation of their networking of the branches. They're looking at how do they avail these, and then ultimately how do they provide end-to-end security. So SD-WAN then is not about IP services over IP. It's about IT over IP. And that's the evolution that we are talking about. We're saying it's SD-WAN 2.0. And hence the difference really is it's SD-WAN 1.0, pure play SD-WAN was all about IP over IP. Now we're transitioning that to IT over IP. And that's the evolution that I was wanting to share with you. Thank you very much.